I know you can't see me, but this is Euclid Book 8, proposition number 8, and I think you can see why you're not going to be able to see me in this one. Look at this thing. Look at the size of this thing. Okay. And if you think the size of the picture's bad, wait until I read you the proof. Ready? If between two numbers there fall numbers in continued proportion with them, then however many numbers fall between them in continued proportion, so many will also fall in continued proportion between the numbers which have the same ratio with the original numbers. And at this point your head is probably going, oh my gosh, what the heck is he talking about? Okay. Let the numbers C and D. Well, here we got C here, we got D right here. Okay, as you can see, the D is obviously bigger than C. Okay. Let the numbers C and D fall between the two numbers A and B. Okay. As you can see here, here's A and here's B. B is obviously bigger than A. And I am sorry this thing is curling up really bad. Okay, so you got B and it's bigger than A, and these two numbers fall between them. Alright, so let me read this one more time. Let the numbers C and D fall between the two numbers A and B in continued proportion. Do you remember me talking about continued proportion in a previous video? Of course you do. And let E be made in the same ratio to F as A is to B. Okay, so now we have E is to F as A is to B. All right. I say that as many numbers as have fallen between A and B in continued proportion, so many will also fall between E and F in continued proportion. Alright, so we're going to say, since we've said that there is a C and D between A and B, so also there will be an M and M between E and F. And don't get M and M scrambled up with the musician. We're not talking about the musician M and M, we're talking about these two lines. Okay. For as many as A, B, C, and D, well, here's A, here's B, here's C, here's A, here's B, here's C, here's D, okay? For as many as A, B, C, and D are a multitude, let so many numbers G, H, K, and L, the least of those which have the same ratio with A, C, D, and B, be taken. So we're going to draw up four new numbers. Here's G, here's H, here's K, here's L. And we can do this by Euclid Book 7, proposition number 33. So if you don't know what we're talking about, go back to Euclid Book 7, proposition number 33. I do have a video on that. Therefore, the extremes of them, G and L, there's G, there's L right there. G and L, those are the extremes. Okay. Therefore, the extremes of them, G and L, are prime to one another. Now, remember, just because two numbers are prime to one another does not necessarily mean that they're prime, period. Okay? There's a difference between prime numbers and numbers that are prime to one another, and I have told you that in previous videos. Okay. And this is by Euclid Book 8, proposition number 3. Now, since A, C, D, and B, that would be these four right here, are in the same ratio with G, H, K, and L, so these are in the same ratio as these, and the multitude of numbers A, C, D, and B is equal to the multitude of numbers G, H, K, and L. So we got four numbers here, we got four numbers here. Therefore, xi quali as A is to B, as A is to B, so is G to L. So as A is to B, so is G is to L. Okay, and that's by Euclid Book 7, proposition number 14. But as A is to B, so is E is to F. So as this is to this, so as this is to that. Therefore, as G is to L, as this is to this, so as this is to this. As G is to L, so as E is to F. Boom. But G and L are prime. Primes are also least. This is by Euclid Book 7, proposition number 21. And the least numbers measure those which have the same ratio, the same number of times, the greater to the greater, and the less to the less, that is, the antecedent to the antecedent, and the consequent to the consequent. And as we all know, that came from Euclid Book 7, proposition number 20. Therefore, G measures E the same number of times that L measures F. G measures E as L measures F. Next, as many times as G measures E, so many times let H and K also measure M and N respectively. Okay, so now we're saying that, let's say that G measures E twice. Let's just say that, okay? Hypothetically, we're going to say that G measures E twice. Well, then we could also say that H measures M twice. And K, which is this one right here, K measures N twice. H measures M twice, K measures N twice. And that's because we said hypothetically that G measures E twice. Okay? Now, you can measure them 3 times, 4 times, 177 times. It doesn't matter. As long as this measures this, the same number of times as this measures this, and this measures that, we're okay. Therefore, G, H, K, and L, that would be these here, measures E, M, M, and F the same number of times. Okay? This measures this the same number of times as this measures this, and this measures this, and this measures that. Okay. Therefore, G, H, K, and L are in the same ratio with E, M, N, and F. This is by Euclid Book 7, definition number 20. But G, H, K, and L, this set right here, are in the same ratio as A, C, D, and B. This ratio right here. Therefore, A, C, D, and B are also in the same ratio as E, M, N, and F. So these are in the same ratio as these. But A, C, D, and B are in a continued proportion, which we talked about in the previous video. Therefore, E, M, N, and F are also in a continued proportion. So if these are in a continued proportion, so these will be in the continued proportion. Therefore, as many numbers as have fallen between A and B in continued proportion with them, so many numbers have also fallen between E, F in continued proportion. Well, we had 2 numbers fall between A and B, and so we also had 2 numbers fall between E and F. And that's your proof. Alright, I will tell you more in my next video. I want you to stay tuned.